book or concepts out of a book. It's a process.
One of the major impacts that this project will have will be the way science teachers teach science.
In 2005, university scientists, junior high science teachers and students, and local communities from 3 separate continents began a global science project. The goal? To teach junior high students how to do real science and then share their results globally. The first step in this process was to introduce the participants to each other. This was accomplished by exchanging trunks. Each participating area put together a trunk designed to introduce themselves to their global science partners.
We had partners from Mongolia, from Mali, from different parts of Montana, even Virginia, and we needed places to tie together so that students could begin to understand each other. So what we did is built a trunk that was representative of our area. And that was quite a project in itself. It represented the agriculture in the area, pictures of the community, personal items from the school. You know, they sent a school sweatshirt along, and they sent sports schedules and things like that, things that junior high kids would connect with. We put them all into this trunk, and so we could exchange it with the partners. And that became an incredible trust-building learning experience. I think it's really, really important if you're using partners in a project to do something to build that relationship.
Well, when the students received a foreign trunk, it was best received if it was presented by someone who had actually been to that foreign country and had used the materials in the trunk. If it was presented by someone actually from the ethnic that the trunk represented, it was a big success, and it was very, very well received.
If there's a chance when you're using international partners to have a representative partner present it, it's definitely by far worth it. From our evaluations and report, it was much, much stronger when the teacher presented the trunk from the United States as compared to the local people just taking it out and reading the thing.
The next step was to look within each local community to find an issue or problem for the focus of their research.
Science research questions originate from science problems. When they end up with a problem in an area, then scientists form hypotheses and they make observations and they finally make a research questions. So we talked about that with students. And then we said our job over the next several months is to find good research questions. But first we need to see what problems do we have that we might address. We got out in the community, and by that I mean walking field trips. We have a potato farm, major grower, a quarter of a mile down the road. So we're able to go down there and visit with him and talk to him. And a neat thing about it is it didn't come up that we didn't say, well, what problem do you have, Mr. Farmer? As he talked and we came back to the classroom, students generated some ideas about, he mentioned he had 4 different fields and had different potato growth in each field, and he really didn't know why. It would seem like that would be a good problem. So out of all that, we came up with a research question. And then we began to devise some experimental designs. How are we going to answer this question? And at that point, our local scientists from the university got involved.
I saw a lot of collaboration in the classroom. I saw the students seeing themselves as part of a team, and a team that they were equals with their teacher and they were equals with the scientists that came in.
Projects spanned across several areas, including production of potato fields near Manhattan, Montana, impact of development on water quality near Belgrade, Montana, cowpea storage in rural villages near Bamako, Mali, malaria prevention and treatment in Mali, and water quality and pollution control in rural Mongolia.
They were very excited when they were in the process of working one-to-one or in a collaborative team with the scientist.
Many times science becomes a book, or it becomes a gee whiz demonstration, or it becomes a list of vocabulary terms or a list of math problems. And as I watch what scientists do in the field and what they do in the lab over the years, it's anything but that. It's exciting, it's dynamic, it's participant driven, it's research driven. It's a real exciting process. And when you start giving kids open-ended inquiry ideas and that they build their own research questions, they're immersed in this. they find out that science doesn't just have one answer.
At the end of the year, the students reported their results, but not just to their teachers. They presented their conclusions in a global science fair that included the students they had been introduced to through the trunks at the beginning of the year, as well as their teachers, the scientists they had worked with throughout the year, and just like real scientists, representatives of the funding agencies who made their projects possible.
Science is not completed until it's shared. And the students understood this. By the end of the year, they understood that they needed to summarize their research and summarize the results and what they thought the future might hold for this project and present it to others in a formal setting.
Students made the question. It's not a question I made and I'm going to guide them through. It's an open-ended inquiry question. They're dealing in real high levels of synthesis, analysis, evaluation, all the time working through that process. They're learning by doing, and when they see results, I don't know the answers. The scientists that we contact at Montana State don't always know the answers. So we're left with some open-ended things that we say, we don't know about this, but maybe we can go further and do an experiment to find that out. That actually happened because it's a 3-year project. From year 2 to year 3, we had some things come up in terms of some of the soil that we didn't know the answers to. The scientists couldn't tell the answers to, and that became the next research question the next year, that particular, why that happened. So we're dealing in real high-level learnings here.
There were a lot of levels of exchange, of learning. Because I was a mentoring scientist, I saw the level of exchange between teachers and the scientist. And I saw a lot of learning, a lot of growing taking place in not just content, but having the encouragement to go out into the community and work with either the parents or to work with some of the farmers nearby.